In this video, we will be looking at aspects of audio and lighting transmission using XLR connectors, whilst also looking at our range of chassis-mounted and cable-mounted connectors and assemblies. We will be reviewing the following aspects of the topic: XLR connector history, design and structure, pin variations and their uses, connector materials, cable processing, unbalanced and balanced audio transmission, phantom power, and the DMX512 protocol within a 5-pin XLR connector. An XLR connector is a robust circular electrical connector widely used in professional audio applications. It is designed to carry balanced audio signals with minimal noise and interference. The name XLR originates from the evolution of the connector series produced by Canon Electric. The original X series connectors were named by James Canon in the mid-20th century. A later revision adding in a latching mechanism created the XL designation. By 1955, Canon introduced a version that incorporated synthetic rubber insulation in the female connector, leading to the XLR name. Although the rubber insulator was eventually replaced with a hard plastic variant, which was marketed as an XLP series, users and manufacturers continue to refer to the connectors as XLR, a name that remains standard today. XLR connectors are available in both male and female versions for both chassis and cable mounting. In most professional audio equipment, the convention is to use female XLR connectors for inputs and male XLR connectors for outputs. This helps prevent accidental short circuits and makes signal flow consistent across devices. The XLR design incorporates an important safety feature. Pin 1, which carries the ground, is deliberately made slightly longer in the female connector. As a result, when a male pin is inserted, the ground connection is made before the signal pins 2 and 3, engage. This sequencing minimises audible pops or static that can occur with other connector types when a signal line makes contact before the ground is established. The robust circular design of XLR connectors provides excellent strain relief, secure locking, and strong resistance to mechanical wear, making them highly reliable for stage, studio, and broadcast environments. Cambridge Electronic Industries have a range of XLR connectors that feature a selection of 3, 4, or 5-pin options. 3-pin XLR connectors are the most common style of XLR connector used and feature in a wide range of equipment used for balanced audio signals, including microphones, with the majority of professional microphones using a male XLR output. Mixing consoles and desks typically feature female XLR inputs from microphones and male outputs to send signals to other equipment. Audio interfaces and preamps. Professional recording studio equipment uses XLR inputs and outputs for high-fidelity signal transmission. Powered speakers. These speakers often connect to a mixer via XLR cables for line-level signals. Signal processing equipment such as effects units, equalizers, harmonizers, limiters, and crossovers use XLR for balanced input and output connections. And studio monitors and headphone amplifiers, where XLR connectors are used for superior noise rejection. 4-pin XLR connectors are used in several types of equipment over 2 differing sectors. Within the broadcast and professional audio market, systems using 4-pin XLRs include intercom systems, where 4-pin XLR is the standard for professional intercom headsets used in broadcast, live events and theatre environments, as it is capable of handling both headphone audio and microphone signal. Headsets used for both mono headphone signals and microphone return signals on a single cable. Microphones, where some desk microphones with indicator LEDs use a 4-pin XLR to power the LED that shows the microphone is on. And audio equipment, powering devices like professional cameras, monitors, and recorders. Whilst within the power and lighting sector, the 4-pin XLR connectors are used for DC power, as a standard for delivering DC power to a variety of equipment including video cameras and other professional gear. Stage lighting, where it is used in some older or specialised applications, such as for power scrollers or colour changing devices. And pyrotechnics, where some pyrotechnic equipment utilises this style of connector. 5-pin XLR connectors are sometimes called DMX connectors, as they are used predominantly in DMX 512 lighting control, which uses 5-pin XLR cables to connect lighting consoles to fixtures, dimmers, and other DMX-compatible devices to control them digitally. Stereo microphones, or those with external power supplies, use a 5-pin XLR to carry two balanced audio signals and a common ground. Stereo intercom headsets use 3 pins for stereo headphone signals, left, right and ground, and 2 pins for an unbalanced microphone signal. And DC power, some audio equipment uses 5-pin XLR connectors to carry DC power. Whilst in aviation, the 5-pin XLR connector can be used for aviation headsets, providing both power and communication, including features like active noise cancellation. The connectors are available in several different styles. Chassis-mounted versions are manufactured with either PA66 nylon or a die-cast zinc body. PA66 nylon bodies provide high mechanical strength, rigidity, and stable performance in high-temperature applications. These connectors are offered in 2 designs, either a circular or square body shape. The body shape does not affect the electrical performance. It simply provides style options for manufacturers when panel mounting the connectors into their equipment. Nylon chassis-mounted connectors are typically fixed behind the equipment panel, leaving only the front interface and any push-button features visible, although it can be fitted to the front of the panel should you wish. All nylon connectors are black and incorporate screw-mounting holes moulded directly into the body. Some of the nylon chassis connectors offer extra grounding with a connection between the ground pin and pin 1. Die-cast zinc connectors are available in 3-pin square body shape or rectangular bodies with 3 to 5-pin configurations. The square body versions can be mounted either on the outside or inside of the equipment panel, offering the ultimate flexibility. The rectangular body versions are usually mounted on the outside surface of the panel, where their front plate provides a clean, finished appearance. Both styles offer greater robustness and support, offering more than 10,000 mating cycles, 10 times the durability of the nylon versions. The zinc bodies are available with either nickel or black chrome plating, providing both durability and an appealing finish. Grounding of the connector chassis is completed via a grounding tab connected to the chassis body. The male chassis-mounted connector pins are precision machined from brass, while the female pins are machined from phosphor bronze. Each is then plated in gold, silver or nickel to ensure excellent conductivity, enhanced electrical performance and long-term corrosion resistance, providing a reliable and functional connection for demanding applications. Nylon chassis-mounted connectors can either be mounted directly to a PCB or via a wire attached from the rear solder bucket of the connector to the required position inside the equipment, whilst die-cast chassis-mounted connectors are only available in solder bucket style. Cable-mounted connectors are typically constructed from 4 main sections: the connector body, the pin and insulator block, the internal cable clamp, and the rear gland with integrated strain relief. The connector bodies are manufactured from die-cast zinc, which is then machine finished to achieve a smooth, sleek surface. They are subsequently plated in nickel, black chrome or satin chrome, or coated with a black paint finish. These coatings provide both an attractive appearance and a durable, corrosion-resistant surface. The pin and insulator block is an integral component of the connector. The insulator block positions the pins in the correct configuration and provides electrical insulation between them. It is produced from PBT polymer, a strong heat-resistant plastic that ensures long-term durability and stable signal performance. Male pins are machined from brass or tellurium copper, while female pins are machined from phosphor bronze or beryllium copper, all materials chosen for their high electrical conductivity and mechanical strength. All pins are then plated in either gold, silver or nickel to enhance conductivity and provide a robust wear-resistant finish. The internal cable clamp is moulded from POM, a stiff high-performance thermoplastic. Its finger-style design grips the cable securely, holding it in place within the connector body. The gland and strain relief are typically combined into a single assembly, though they are made from different materials. The gland is produced from either metal or ABS plastic and features a screw thread for attaching to the connector body. The integrated strain relief is manufactured from TPR or PVC and provides a rubberized high-friction support that protects the cable. By absorbing stress from pulling, bending or vibration, it prevents damage at the connection point and ensures long-term reliability. The cable connectors are assembled by first threading the cable through the strain relief and gland and then through the internal cable clamp. Once positioned, the cable conductors can be soldered into the solder buckets on the rear of the pin and insulator block. After soldering is complete, the pin and insulator block, together with the cable clamp, are inserted into the connector body and pushed fully into position. The gland and strain relief are then brought forward over the connector body and screwed securely in place. This completes the cable assembly, resulting in a clean, reliable and visually refined finish. Audio systems use both arrangements of unbalanced and balanced transmission, with unbalanced systems being seen more in the consumer electronics environment, whilst balanced systems are being used in professional setups. Unbalanced systems are quite straightforward in design and easy to use. They carry the signal on a single conductor with a ground wire which is used as a shield. This simple design is cost-effective and works well for short cable runs, but without the noise-cancelling features of balanced audio, unbalanced cables are more prone to interference from EMI and RFI, with this interference degrading the audio quality. Balanced audio uses the three-wire connections, positive or hot, negative or cold, and ground, to transmit signals effectively whilst cancelling the effects of electromagnetic interference and noise on the signal. The same signal is sent along the hot and cold wires, with one in the opposite polarity to the other. At the receiving end, one signal is flipped back, cancelling out the noise, while doubling the audio signal strength, resulting in a cleaner sound transmission over longer cable runs. Standard pinout of a 3-pin XLR connector is: pin 1 is the ground or shield. This prevents the interference and gives a reference point. Pin 2 is the hot or positive. This is the non-inverted audio signal. And pin 3 is the cold or negative, and this carries the inverted audio signal. The XLR connector gives a superior audio quality as they offer an easy-to-use balanced interconnection system that can offer a superior sound quality over long distances. It is often preferred to other connector types as it offers a locking mechanism, offering a secure connection on stage or in a studio. Balanced wiring provides low noise and long cable runs. A robust metal design making them a durable, reliable connection option. And a standardised pinout, ensuring compatibility across brands. The voltage handling capacity of an XLR connector depends on its configuration and intended application. Standard XLR cables used purely for audio typically operate at low signal levels, carrying voltages up to around 15 volts. Some equipment, such as condenser microphones, requires an external power source. In these cases, a 3-pin XLR connector can deliver power without the need for a separate battery pack. This is accomplished by applying DC voltage equally to the two signal lines while referencing the supply to pin 1 ground. This method of delivering power is known as phantom power. Phantom power is most commonly supplied at 48 volts DC, although lower voltages are also permissible depending on the microphone's requirements. Modern audio mixers frequently include built-in, switch-controlled 48-volt phantom power supplies. These can provide phantom power to individual microphone inputs or to all of them simultaneously, eliminating the need for external power units on each microphone. DMX512 is a unidirectional asynchronous serial digital protocol used to control lighting fixtures and stage effects. It is transmitted over a balanced shielded twisted pair cable and typically uses XLR connectors. To ensure proper signal integrity, a dedicated DMX cable with a characteristic impedance of 120 ohms is required. Standard microphone and audio XLR cables, which typically have an impedance of around 75 ohms, are not recommended, as the mismatch can cause signal reflections, data errors, flickering, and other reliability issues. The official DMX 512 standard specifies the use of a 5-pin XLR connector. The standard 5-pin XLR pinout for DMX 512 is: Pin 1 is your signal common or ground. Pin 2 is your negative primary data link. Pin 3 is your positive primary data link. Pin 4 is your negative secondary data link. And pin 5 is your positive secondary data link. Despite being prohibited by the standard, many installations use 3-pin XLR connectors for convenience or cost reasons. However, this introduces risks including potential equipment damage if the cable is accidentally plugged into audio gear that supplies 48-volt phantom power. Since 3-pin XLR cables are designed for audio rather than data transmission, their use can also degrade signal quality and reduce system reliability. In summary, there are many reasons to choose an XLR connector over other connector types. They offer balanced transmission. XLR connectors support balanced audio, ensuring signal purity is maintained even over long cable runs. They have strong anti-interference performance. Their balanced design and shielding provide excellent resistance to external noise, helping to prevent distortion during transmission. They provide a stable, secure connection. The mechanical strength, defined insertion force, and positive latching mechanism ensure a reliable and secure connection in demanding environments. They have wide compatibility. As a fully standardized interface, XLR connectors are universally compatible with equipment across the professional audio industry, making our cable products suitable for any XLR-based application, and offer versatility across applications. XLR connectors are used not only in professional audio environments such as recording studios, live sound and stage performances, but also in broadcasting, podcasting, conference systems and many other fields. With the growth of social media and influencer-driven content, more creators are adopting high-quality recording equipment, making XLR connectivity increasingly common outside traditional pro audio settings. We hope this has given an insight into the range of XLR connectors we have at Cambridge Electronic Industries. We are also able to offer fully assembled cables to standard or bespoke specifications and are happy to assist with technical help and expertise. If you would like further information, either have a look at our website or contact us on sales@cambridgeelectronics.com, where we'll be able to help with your inquiry.